Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. So this is on to part 2 of this saga, this Marantz 1122 DC. Like I said in the last when I left off, it still had a lot of problems, but we're going to get into that. We're going to fix it, and we're going to get it working good again because it's not going to leave this bench until it's working 100%. So let's get on with the video, and hope you enjoy it. Let's turn up the sensitivity of this. 100 millivolts a channel. See, it's twitching around. So I might still have troubles with problems with the tone amplifier on this. And we are getting some weird signal on the right channel. That is something I've never seen before. Okay, I got a voltmeter here. It's a 100 volt scale, and I got 50, 51, 52 volts on this orange line that goes to the tone board. And I'm watching it. It's pretty stable, but it's also fluctuating a little bit. I can see that needle moving ever so slightly, but I'm on a 100 volt scale, so I'm not going to be seeing any small differences in voltage, but I do see it moving. Okay, so let's measure the voltage coming out of the power supply coming to the phono board. I have it connected to a voltmeter, and let's see here, voltmeter and scope. You connect both up here, and our scope is on screen. You should be able to see it. Let's turn it on. Our voltage goes up to 79 volts, and here's our click, and you can see our voltage is pretty stable. It's not jumping around. So our power supply is not the culprit here. Let me move the probe to the output of those two, the other side of those two resistors. And there it is. And you can see it here jumping around a bit. It is twitching. Let me hook an ammeter up here and see what the current looks like. Something is going on in this tone board that is not sucking current properly. Anything here has an effect on it? I don't think so. I think it's all internal. Okay, let me try an ammeter. Okay, so I have an ammeter in series with the wire coming out of the phono board going here to the tone board. Let's turn it on and let's see what we get. 300 milliamp scale. We're getting probably less than 10 milliamps. Here's a 30 milliamp scale. We're getting about 13 milliamps load. So I'm going to watch this needle for a bit. I don't see it moving. Don't see anything moving at 13 milliamps. Okay. I can see it twitching on the scope, but I don't see it twitching on the current meter. So what we're dealing with is a very small, minute amount of energy that's moving up and down. Alright, I'm wiring the scope. I got the scope monitoring both outputs of this tone board. This output goes to the back panel, which then goes to the switch for AC-DC coupling and then goes back into the power amplifiers. I've disconnected both power amplifiers inputs, so I don't want any signals back feeding. I don't think there would be, but just to be 100%. So there's our, this meter is connected across the power supply for this board, so it's showing 92 millivolts right now. It's turned off and I got it plugged in, so let's turn this on and let's do a little bit of troubleshooting here and see if we can figure out why we have a twitchy amplifier output. Now right off the bat I see something that's really helpful in it. Both channels are twitching at the same pace. You see they both track each other. Now if I turn off my lights, you'll see that the hash goes away quite a bit. So those spikes and everything you see on there, that's all interference that's being induced into the circuit. Now, another thing I want to show you is this voltage here, 47.2 and rising. And I'll just let this cook for a while, and you see it slowly comes up. There's no regulation on this power supply for this board, so that's a fail on Marantz itself, I think, because they cheaped out and they just put a resistor dropper in there to drop the voltage to what this should be 43 volts, but we're at 47, and I think if you watch it climbs up to 50 volts. Now what I had wanted to do was probe around this amplifier and see if we can figure out where this noise is coming from, but it seems like it affects both channels, so I don't think it's tied to one amplifier alone, unless the one amplifier is consuming current at a weird rate and the voltage is jumping around. You see how it's jumping around so bad now. I have it on a 10 millivolts per division scale. This keeps going up slowly, and this kind of twitches too. It goes up and down. If you watch it, it goes up a bit and then it goes back down, but right now it's still doing a steady climb until it gets about 50 volts and then it stabilizes. I'm just going to let this go for a while, and yeah. So another thing I want to point out while we're waiting here, let's just look at the schematic. Okay, so we have power coming in here, plus 43 volts, and it goes, this line feeds these two amplifiers, it goes up and over, and this line feeds these two amplifiers. Now, we have a tone defeat switch here, and from what I can see, depending on the switch position, it takes the output signal, which is this line here, and goes to the next switch, which is the high filter, and then it goes through the high filter and continues on to this switch here, which is a low filter networks. But if these switches are switched out of the circuit, it goes straight out to these two pins here. This is the output I'm scoping right now. So the tone defeat switch chooses between this set of amplifiers or this set of amplifiers. If you follow the connection, this one comes down here, it connects to these two lower pins. These ones here come down here and connect to these two upper pins. And this is a double pull, double throw. So you can select between one or the other. Either you select from this amplifier or this amplifier. Tone defeat, press the tone defeat in. You're selecting from this amplifier, which has no tone controls. If you take this switch out, the tone controls are active, so you're actually taking the signal from all through here and you're taking the tone from there. Another thing to notice, this is the balance pot, okay, and this is the volume pot. So they are both before any signal processing, so they have absolutely no effect. When I turn the volume, crank it right up, we have no effect on the output. You can see the voltage came up to 50.2 2.5, and it's sitting there, and it's still slowly climbing, but it's also going up and down now. It's kind of reaching that equilibrium point where it's starting to twitch and go up and down. So my plan was to scope at the outputs of these 4 amplifiers to see if we can isolate where this noise is coming from. But from looking at the scope, it's in both channels. So it's something common for both channels. It's either a poor ground, or a dirty power supply, or, well, that's pretty much it. That's all it can be. And I think we have to go with that. So I am going to scope the collector of this transistor QE04, collector of this QE03, and the collector of QE05 and QE06. I want to see if we have any noise at these 4 points that would be the cause of this. So I marked the points where I want to do probing. So let's check the first one. And you can see we are not in phase anymore with the other channel. It seems like it's kind of following, but it's not really. Let's try this point. Wait for it to settle. Same thing here. Okay, let's go over here. Try these two. You got it marked on the board where I need to probe. There's one. It's not even following, it's like it's inverted. Okay, let's try this one. I don't think that is where this noise is coming from. I don't think it's coming from those transistors. Let me probe the power going into this thing. Yeah, there's the power going in on the top trace. Similar, but not identical to the bottom trace. I think we have a bad divider resistor here somewhere. Could possibly be one of these caps I installed is faulty. That's another possibility. I have some 22 microfarad at 50 volts. 1, 2. I have a 0.47 at 50 volts. I think that was replaced with a film. 4.7 at 50 volts. That is on a signal output. That is a coupling capacitor, a DC blocking. Here's another one, 3.3. These are blocking, so I don't think that's part of the problem. This was going to be tough to track down. So let me probe around some more. And you see our voltage has climbed up to 50.8 now. Alright, what I'm going to do is I'm going to isolate this power supply, isolate this one, and I'm going to feed it power from my bench supply, and we're going to see if we still have the same twitchiness. Mainly I want to bypass these 2 resistors that are used as a dropper for feeding this board. So I have everything connected. Let's power this up. If I can get my hand in here, turn that on. And you can see the output of the 2 channels is running steady because there's no power feeding them. And this voltmeter will show you what I'm feeding for power. So we got here, let's turn this on. And let's start ramping up the voltage. I'm going to go up to 43 volts. You're going to see lots of twitching going on the scope as I ramp this up. $30, $43, very noisy. Okay, we're drawing 15 milliamps at 45 volts, and you can see we still have our twitching. So that tells us it's not a power supply issue. Something definitely going on this board that is not kosher. My hand on there, it gets a lot of noise. Okay, let's focus our attention on that board then. So like I always say, divide and conquer. So what I did is I removed the board from the amplifier and I'm powering it up for my bench supply, and I'm scoping the output terminals here. And yeah, it's still doing its twitchy thing. So there's something definitely on this board that is causing this. It's not going to be easy to find because when I probe around, it's such a small, minute signal that it's really difficult to get a reading. But I have been poking around at these transistors, and I do see, for example, I'll show you. You can see that they are still very twitchy. You see that voltage jumping around there, a few millivolts, up and down, up and down, up and down all day long. So here's the other side of that transistor. Same kind of thing. It's still unstable. This one, the other amplifier, same thing. So I don't know which one of these 4 amplifiers is causing this problem. So what I intend to do is just disable them all and then bring one at a time back online. For example, I can remove this 3.3K resistor, or lift one leg of it, and that'll turn power off to this section. It'll still flow through this 220K, 6.8K to ground, but this is biasing for that. So I can turn this set of transistors off by removing this resistor, or disconnecting it. Same with this one. I can turn this pair off by removing or disconnecting this resistor. This pair here, this 1.1K, there's two 1.1Ks, I can lift that one and that will shut off the ground for that one, and that will provide me with 4 dead circuits, and then I can turn one on at a time and I can see which one's causing the upset. So I think I'll do that now. 3.3 is here, 1.1 is here and here. So I'll lift those 4 resistors and then I'll bring you back in. Alright, so I've done some preliminary work here. I removed this resistor, and these 2. Now when you can see the screen there, when I reestablish this connection, you'll see, let me see if I can get a pair of tweezers here or something. Reestablish that connection, you can see it on the screen. Getting a lot of noise coming through there, but it doesn't seem to be twitching around like, it seems okay. Let me see if I can get a better, I need something insulating. Something like this. Okay. Now I don't see too much going on there, so I'm going to lift that one back up. And I'm going to establish the connection on this amplifier. And you can see it basically does the same thing. I'm feeding 43 volts onto the board right now. So it seems stable, it doesn't jump around a lot. The active channel is the top one. So let's remove that. Okay, so I think these 2 amplifiers are okay, and I'll explain why here in a second. Let's do the same for this side. Let's connect this resistor on this pair of transistors and get this side working again. And then you'll see on the top trace, if I get a connection here, I think I have a connection. Now it's behaving. Let's try the other one. It was a very different story before I turned the camera on. Something mystery here. Let's reestablish this connection. Okay, you can see how that is all over the place, right? We definitely have a problem on that amplifier. But this one here is stable. Okay, if I connect both amplifiers, I don't think I have one amplifier working here. Top trace is not working. Let me investigate some more. Alright, I think I discovered the cause of the unstable noise, and it's totally my screw up. Let me explain. I was racking my brain as to what was going on here. I eliminated this section, and I noticed that the noise was coming from this section. And so what I did is I swapped parts around. I replaced actually 7 resistors. I was pulling these resistors out and testing them for noise. And while some of them were kind of noisy, some of them weren't. So just to rule it out, I replaced them, right? They were cheap, easy parts to replace. That didn't cure it. But what I did now is decided to switch strategies, and I started pulling out capacitors. I pulled out these 2 DC blocking capacitors from the input, and they're 1 microfarad, just to eliminate them from leaking, or that's the cause, and no change. Then I removed this capacitor here, CE87. CE87 is this one here. Now this is a plus 43 volt line, and this 150K resistor and this 16K resistor creates a divider network. And I think they're going for almost 10 to 1 here, or 9 to 1. So this voltage here will be divided by this string. And there's a 22 microfarad cap here that's reducing noise on this resistor, this 150K. I pulled that cap out and the noise went away. And then I looked at the cap. The capacitor I put in here is a 22 microfarad at 25 volts. Well, this is a 50 volt cap rated, 50 volt rated cap, and the voltage across here is probably more than 25 volts. So I think this capacitor was breaking down, and that's what was causing the micro leakage that was causing the imbalance and the twitching. So even though the cap didn't fail, and it didn't fail catastrophically, like hard short or blow up or anything, there's just not enough current for that. It was leaking current, and it was upsetting this voltage divider. So that's my theory anyway. So I'm going to replace that with a 50 volt cap now, and I don't know how I missed that. When I pulled that cap out, if it was I can't remember now if it was 25 or 50 volt cap, but I put a 25 in. Maybe I grabbed this by mistake and put it in, and that was the result. It causes a lot of upset in the circuit. Now, spent almost a day and a half trying to troubleshoot this, figure it out. Yeah, it was frustrating, but we'll put this cap in, this new cap. This is a 50 volt 22 microfarad, and we'll see if that solves our problem. So here's another example of a total screw up on Marantz's schematics. What they have in their schematic does not match real life. And here's an example. So this line here going across the top, this is a 43 volt supply that comes in, and then it goes through this 150k resistor down through a 16k resistor to ground. And they show the capacitor bridged across this 150k. But in reality, this capacitor is not. It is bridged across the 16k. And it's confusing here because they specify a 50 volt cap for here, which has about a 40 volt drop across. But this cap is actually here, where there's only like a 2.6 volt drop. Isn't that something, eh? I'm still getting twitching on this line though. I measure it with a voltmeter and it's jumping up and down. This voltage source here from this divider, and this just biases these transistors, I think. So I think I'm going to add a capacitor here across this 150k, and I'll see if that smartens it up. We already have the cap across the 16k, but I'll add another one here. See, this Marantz, these schematics are just terrible. Just terrible. None of the values match either. For example, they have 560k here, 560k here, but in reality these are 220k. And yeah, it's not. Another example, 0.47 at 50 volts, 0.47. In reality they're 1 microfarad. Everything's changed on this. It's really frustrating to work on these Marantzes. Okay, the plot thickens here because this is not cool. Not only was this capacitor, when I said was undervoltaged, or it was underrated for the voltage, is correct, it's correct size, it's in reverse. So the positive is marked on the wrong side here. The positive should actually be the negative, because if we follow the circuit and yeah, so the cap across this 16k was in reverse. Maybe that's why I had all of this twitchiness, because it was actually bleeding current through this capacitor. And I think that's the cause of what I was experiencing. So I had 43, 45 volts on this line, no capacitor across the 150, a reverse bias capacitor across the 16. There's only about 2 to 4 volts here, but that cap was leaking current and causing that to twitch. So yeah, thank you Marantz for your crappy schematics that don't make any sense. So what am I going to do here? I'm going to reverse this one. This one's going in reverse from what it says on the board. Oh boy. And this one here I added. I don't know if I'll leave it in or maybe I'll just leave it in. It's not going to harm anything. 2 capacitors, and then it's got the resistor divider network. It should keep it nice and stable. It shouldn't upset anything. So we're going to put this together now the proper way. When I recap this, I honestly can't remember if I was checking them and they seem to be correct, but they must have had this one in backwards without, because it's not silkscreened properly. Alright, so I have this here. Let's connect the power up again. This one's here, this one's there, everything's good. Okay, turning power on. Let's measure this voltage, because it was twitchy all over the time. I was reading it with my voltmeter and it was really twitchy. It was jumping up and down. And okay, so here is 16k. That's ground. 4.57. And now it's stable. Before it was jumping up and down almost 1/10 of a volt. And it was because that cap was in reverse and was leaking current. And it wasn't doing it consistently, it was twitching all over. So that's good now. So across this cap we have 42 volts. And across this cap we have Come on now. 4.5 volts. Perfect. So it's done. On to the next part. Alright, just a quick test here. I got everything back together. I want to make sure I got this back in, the tone board, after finding that fault. Now we got another problem to deal with, is the oscillation in the power amplifier. I got it hooked up to a load and scope. And just going to do a quick test just to see. Turn it on. Get a relay. Okay, I want to turn this up and see. Okay, I got it back up. Let's look at the scope. Quick. Let's see what we got here. Turn it up. We got our sine wave. And we have our oscillation. Keep going, keep going. And it clicks off. So we need to figure out why that one channel, that right channel, which channel is it? This one? You unplug one channel at a time here. No. Okay. So it's that channel, the right channel. Okay, have a look at this waveform. Now I'm really torn between thinking if this is an oscillation, it's a really weird one. I think it's more of a breakdown. Watch, if I turn up the volume on the bottom trace here, you see it starts to break down. It's almost like as if a transistor is breaking down from over voltage or something. And if I increase the volume, watch the top of the waveform. I can't get it to increase any higher than what it is. It just kind of flat tops. So if I start increasing it, you see it's flat tops. It's almost like it can't do any more than what it can, like because that transistor is breaking down. It's right at that point too. So I think I might have a bad transistor in here somewhere. But which one? It's on the positive portion of the waveform. So that gives me a clue which side to look on. Let me see here. If I got channel 2, I'm going to raise this up so I can see the entire waveform. It looks like it's breaking down and the current spiking. Turn it up more. I got it on 100 hertz tone right now. It's really, I'm just trying to slow it down so I can see what's going on here. I can slow it down more. Let's go to 50 hertz. You can see. And there's, I'm poking around with my scope here on the top. Here, let's look at this here. And there's current spikes that are going through the entire amplifier, and it's upsetting everything. Let's see here. Q716. Let's have a look at the emitter. You see the current spikes there on that emitter. Let's go to the collector. If I can find the collector here, it's very difficult to probe this board. There's collector, and then the base is insulated. I can't tap into the base. Base would be part of that resistor. 36. Where is 36? If I go to the emitter, you see the spikes. I'm actually probing a negative source here, so the positive going spikes are actually drops in voltage, not gains. And if I look at the collector again, it's right in lockstep with the other. Maybe it's that transistor. I don't know. I'll show you what I'm looking at here. So I was just probing around Q716 here. The collector has large spikes on it. The emitter and base have minimal spikes. Alright, so this is how I'm gonna go about this. Troubleshooting these oscillations has to be probably one of the most difficult things in amplifier repair. But I'm not going to give up. I don't give up that easily, if you know me. So this is what I did. You got to test this somehow. So we must be able to power it up, right? So what I've done is I've jumpered from this connector. This is a 5-pin connector here. Actually 6 pins, but 2 of them are grounds. So I got my B+, B-. I got the speaker outputs going back to the unit, and I got my ground wire, and I've actually got a signal jumpered in too on this side, and that is all tied into the Marantz power supply. So I got the power supply feeding the board just like it would be if it was plugged in and installed. So I'm able to turn on the amplifier and control it with all the controls on the front, and actually on the rear I put a light load. This is 15 ohm per channel load. This is a very light load. I'm not doing full testing here. I'm just getting a sense of why it's oscillating and what I can do to stop it. So I got a load on here, and just to keep everything stable and happy. So, where do I start? It's a good question. I'm not an expert on this kind of stuff, so I don't know too much about it, but I'm going to try my best. So, this side here is the one that's oscillating, and you know, obviously I've inspected this. There's no bridges, there's no gaps, there's no cracks. Everything's good. It's been worked over. If I flip it over, I can flip it over and work on this side as well. I can probe, and remove parts, take parts, put parts in. One thing I did notice about this Marantz, I'm not really happy about the design of these Marantz. This one in particular, I've seen a lot of shortcomings in the design, electronics. Here's one of them. This one's really, I don't know. These 4 capacitors here in the center, these are power supply filters. As the power comes in this connector, goes up, and it's filtered by these 4 caps. 2 for this side, 2 for this side, and 1 for the positive rail, 1 for the negative rail. These were 47 microfarad, so I upsized these to 100 microfarad each, just to give it a fighting chance. The other capacitors I replaced is this one here in the center, and then there's these 2 on each channel here on the outside. This circuit here is, from what I can tell, is the part of the protect circuit. So this is monitoring the output of the amplifier for DC, overload, and whatever else they're doing there. So these caps are part of that, so that's not a worry. There's 4 caps here along the back. These caps here are just power supply stability for, let's see here. For example, the Zener has a 22 across it, and I think there's another one. This Zener has a 22 across it. So that's what they're doing here. They got a Zener diode providing a stable voltage source, and the capacitor is just making sure that that is a clean signal, clean filtering. So I'm suspecting it's these drivers that are oscillating on this channel. I'm not 100% sure, but when I do the scoping on a lot of the amplifier, I'm seeing voltage spikes everywhere. That's why I'm saying these capacitors are kind of, I don't know, they probably perform well enough in a normal amplifier, but when you get an oscillation, these are inadequate. There's a lot of voltage spikes going on when the thing oscillates, and it's really wild oscillations, so the whole circuit's affected, not just one portion of it. That's why it's so difficult to track it down. So I'm going to keep going here. One thing I want to do is I want to put this aside because I have other projects, other repairs that are waiting. So this one's been consuming so much of my time, I can't continue on. I will continue on, but I can't continue on right now. I need to put it aside and get some other stuff done. It is kind of a complex circuit. This is all one channel. We have our outputs. Our outputs are off board. Okay, these are outputs down here. These are drivers, pre-drivers. No, sorry. This here is the protection circuit, part of the protection circuit, and they have a different numbering scheme for the ones. There's Q728, 726 here, and then they have QT02, T04. So they have a different numbering scheme for the parts that are part of the protection circuit. That's my take on it anyway. So you have your drivers, or pre-drivers, a differential circuit here. This is the dual FET differential here. Everything seems to be working normally up to that certain point where it breaks out in oscillation. I'm going to keep slugging through this. I'm going to try different things here. Okay, I think I made some progress here. Now, what I decided to do was probably, most people would probably think it's a waste of time, but I don't. I think it's a very good method. If you're all out of options, you just use the brute force method. So what's the brute force method? Is you have one working channel and one channel that's misbehaving. So what I started doing is I started swapping components from one channel to the next, and I kept going. And how many do I get through? 1, 2, 3, 4, 5, 6, 7, 13 or 14 different transistors. I finally hit upon it. So this transistor here is Q716, and its partner next door is Q715. So I pulled out these two. I was going to swap them. Checked the beta on them. One was around 250, just over 200, and the other one was over 400. So I swapped their locations, and guess what happened? If I turn it on, I'll show you here. Wait for the protect to click in. There we go. Now I increase the volume, and before I was getting the feedback on the bottom blue channel there, now it's on the top. So I transplanted the problem from one channel to the other by moving those two components, and that's the cause. That was found the cause by that. So like I said, it's a brute force method, swapping parts from one channel to the next. You know you have a perfectly good working channel, and you have one that's dead. So, and if you can't seem to figure out why it's doing what it's doing, swap parts from one to the other, and any characteristic that you swap with it will transfer from one channel to the next. It's called divide and conquer. You just knuckle down and start swapping parts, and then eventually you'll hit upon it. So yeah, it's this one here, and this one, what does this transistor do? Not entirely sure. It's part of the voltage amplification section. So what I'm going to do, this is a 2SC1775, so I'll have to find a good replacement for this that has the right beta range, and this thing should be ready to go. Alright, so what I decided to do is I replaced the 2SC1775 with 2SC1845. Characteristics are very similar. They have the same gain range. It's a basic high voltage, or high voltage by 120 volts. That's what I mean by high voltage. Fast transistor, that's for audio. And as well as replacing that, I replaced the complement to it with the original was a 2SA872, and I replaced it with 2SA992. So those two should be happy there, and let's give it a test. I'm going to turn it on. Okay, fire in the hole. We're going to go live. Power on. Just waiting for the relay click. There we go. Let's turn it up. Oh, this is looking good. Got full power to clipping. Okay, excellent. So what I'm going to do now is remove all these wires, get everything buttoned back up again, put it all together, and we're going to do a final test on this. Everything's working good now, and I'm really pleased about that because it was really racking my brains. Alright, we are back together, and we're going to do our power test. First one. Let's see here, you got 1000 hertz tone going in, the usual 8 ohm load, blah blah blah. Okay, let's turn this on. We're all set up. I hope you can see the watt meter there. Relay should click. There it is. Okay. So I gotta set my scale on the scope. Okay. It should be better. He's clipping already. Let's give her a little bit more. Here we go. Okay, so we have clipping starting at the top. Right about here, I'd say. It's just touching now. It's 24.99 volts RMS. That's the top trace, the left channel. Let's just let this run for a while at this output, and we'll see how it holds up. We're probably at the 4-minute mark now, and this is just starting to get warm. It's not hot yet, but we're going to keep it going for a while longer here. Alright, we're about the 7-minute mark. It's just starting to get hot now. I think it's done proving its point. It's a very capable amplifier. It's got adequate heat sinking, and it's got the power to deliver the goods. Okay, let's try a square wave. This is tone controls defeated. Wow, that's a nice square wave. You're doing pretty good on that one. Nice, clean. Let's go up in frequency. What do we got here? 4, 5, 6, 7, 8 kilohertz. Still looking good. It's one of the best square waves I've seen in a long time. Where are we now? We're at 23 kilohertz. That looks pretty good for 23 kilohertz. Usually it's morphed into a sine wave by this time. Well, that's very good. Fast amplifier, and it's got some really nice response rise times. Let's go back down. It's 5 kilohertz right there. Let's go down to 1 kilohertz. Okay, tone controls are defeated. Let's turn the tone controls on. Okay. Bass cut. Bass boost. Mid-range cut. Mid-range boost. Treble boost. Treble cut. A little bit of ringing there. I don't know what that's about. Looks like that tone amplifier wants to ring a bit. It's a very fast amplifier though. It's got a good square wave. You can doctor this up to make it perfect right there. Okay, balance control is good. Low filter, high filter. Switch dirty. That high filter takes out that ring. And loudness, finally. That's the effect of the loudness control. And that's it. Everything else is straight through. Alright. Looks good. So there it is, it's finished, thankfully. And this one's going to go on the listening bench for a while. I'm kind of interested in hearing how this sounds. I think it's a really good performer, according to what I saw so far, just on that little bit of a test. So this is all that went into it, a handful of capacitors. Majority of these didn't need replacing, but doing a full recap, you might as well just get rid of all these old 45-year-old caps and just replace them with brand new. And then we replaced some troublesome transistors, some that were on our naughty list, and then some that were causing problems. And there's a pile of transistors there, that's all it needed. Nice cleaning, fixed up the balance potentiometer, so that's working now. And everything's ready to go. So it's a nice looker. I like this chunky aluminum look. It's one of my favorites. So yeah, if you like this kind of stuff, stay tuned, because we got more coming up, and I got some really interesting pieces waiting for the bench right now. So hope to see you on those ones. So take care, talk to you later, and hope you're all well, and see you in the next video. Thanks for watching.